So global warming or global climate change is just this idea that temperature as a whole is actually not just changing by the seasons, but it's changing and increasing over time, right? So if you take the average temperature of the Earth and you plot it every year, right, you will get a graph that looks something like this, right, where the temperature goes up and up. Now, keep in mind, we're scientists, we're not politicians, we don't just interpret graphs the way we want and manipulate things. So don't forget on all of these graphs, because a lot of these may have been these graphs that we have gotten that are in books or on the internet or wherever you might find them. Okay, a lot of them you will find will be posted by someone who has an agenda, someone who's trying to convince people of stuff, right? So oftentimes they will manipulate the graphs. Keep in mind, so this graph right here, look at the graph, look at the axes of the graph and make sure you understand. So this is over 130 years of time. And you'll notice that the temperature does rise, and that is true. It has been rising, but notice the temperature difference, right? 0 is supposed to be the temperature that you would expect the Earth to be at. So at first it was colder than what we normally expect the Earth to be at, and then it warmed up more and more and more and more. And the actual temperature changes from negative 0.2 up to, I don't know, negative 0.5 or something. So that's a change in temperature of about 0.7 degrees. That's not very much, right? But it is a change in temperature, and actually a little bit of change actually does cause a difference, and it makes a difference. However, just keep in mind that this looks like a huge increase. It's just 0.7, so always make sure you look at your axes. Now, the average temperatures are currently close to an all-time high for the last 400,000 years. Okay, so we're going to look at how do we even know that? How do we even know the temperature? In fact, at this time we want to discuss what are the possible sources or reasons why this temperature might increase. Okay, so if you want, you can pause and try and guess. Here are some of my ideas of what, and other scientists' ideas of what might be causing this. Okay, one of them, of course, is the most commonly accepted one from a lot of scientists, and that is that the changes in the composition of the greenhouse gases in the atmosphere could be affecting this. So in other words, if we get more greenhouse gases, we'll hold in more energy, and therefore it'll warm up, right? So also other ideas could be that there is an increase in solar flare activity, which is true. It has been increasing. A solar flare is basically like a giant explosion on the surface of the sun, which spews stuff out in the air, or sorry, not out in the air, but out away from the sun. It does come back in, but at the same time, it increases the solar radiation. So it gives it a burst of energy, or shoots out a burst of energy from the sun all at once, and so that means that the actual energy coming off the sun is ever so slightly higher than what it would normally be if there weren't as many solar flares. So it could be that's the reason why the temperature is increasing. It could also be the fact that the Earth's orbit is changing ever so slightly, right? If we ever get a little bit closer to the Earth, if the Earth ever gets a little bit closer to the sun, then that means our intensity will go down because we're getting energy when we're closer, and it'll be a smaller surface area. Okay. Also, it could be even volcanic activity. Right? The Earth also has an internal temperature, and it's really warm in the inside, and so it could warm up the outside by having a lot of volcanic activity and bringing some of that internal heat out. And that is true that we have had an increase in volcanic activity recently. So which one of these reasons is probably accepted by many scientists? And the one that we're going to be focusing on today is the top one, the idea that perhaps it's increasing because the changes in composition of greenhouse gases in the atmosphere. That's the one we're going to be focusing on, but it could be other ones of these, and other scientists will argue one or the other. Okay, so it's not necessarily, we don't know for sure it's this top one, but a lot of scientists believe it's that one. There better be a reason for us believing it, right? Again, we're not politicians. We don't just pick whichever one we like and we go with that. We're going to pick the one that we have the most reason to believe. So there should be some evidence for us to believe this. So what are some of these reasons why some scientists believe an increase in greenhouse gases is causing the temperature to rise? Well, in order to really know, we actually have to look back in time. We actually have to look and see a trend, and that means that we need to see the percentage of greenhouse gases and compare it to the temperature over a long period of time. It's hard to do that. One of the ways we do that is by looking at ice cores. So what they did is they go to Antarctica and they drill down and they get out this core of ice. So they drill down with this drill and they pull out this core of ice like this girl is holding right here. And this core of ice, similar to a tree, which has different rings around it, has different levels or layers of ice. So just like a tree, right, you can look back hundreds of years, many years in a tree by the rings, and you can see, like, you can tell if there was a drought one year because the ring might be really thin, or if there's a black ring, maybe there was a forest fire one year. And it's kind of like looking back in time by looking at the rings. Similarly, snow falls every year and freezes, right? And when it falls, it gathers information about the atmosphere because it's passing through the atmosphere and gathers some of those chemicals or whatever's in the atmosphere at that time. So if you drill down through the ice, it's like drilling back in time, all these different layers from past years and hundreds of thousands of years ago, and you can look at all of these different layers and you can gather information and you can learn what the gas concentration was during those years. They have done this for hundreds and thousands of years to get the information, and you'll find that information in the following graph. This graph here is an example of the CO2 concentrations found in the atmosphere. Again, don't forget to look at the axes. Notice that this is a skewed graph. It doesn't actually go down to zero like it should. So this looks like it's like the concentration of CO2 is actually almost zero at this point. It's not. They're just trying to make the difference more extreme, okay, by zooming up. Keep in mind that this graph is actually longer and the extremes aren't quite as much, but it's still going up and down. And so from the beginning of time, so 400,000 years ago on the Earth is how far back they're looking at this. Okay, and they've noticed that at different times the CO2 level is really high, and then it goes down, and then it goes up, and then it goes down. And the Earth actually has a natural fluctuation of carbon dioxide. So there are natural causes for why carbon dioxide might increase and decrease and increase and decrease. Okay, this is even before where humans are on the Earth, right? So there's got to be some kind of natural reason for this. As we zoom up on the last 8,000 years or so, though, you'll notice an interesting trend. It stays relatively constant, and if you zoomed up on any part of the other graph, right, even though it went up and down and up and down, this is over hundreds of thousands of years, right? So these changes aren't actually that quick. They're kind of subtle. So when we zoom in, we should see even more subtle changes. Like this is a slow increase, right? A subtle change. But you can see right around the Industrial Revolution, boop, it jumps right up. Okay, and this is around the time when we were building devices that burn fossil fuels. So if we zoom up one more time, just in the last 50 years, right, you can see it go up and up and up even more. This is a very large spike for just 50 years. That's a very, very fast spike, which is very unusual for the rest of the time. Okay, it usually never jumps up quite that fast. You can see similar trends with methane gas. Okay, and again, near the end, you see this giant spike of methane gas. Again, zooming up. Okay, however, why does this mean that this might be causing temperature change? Just because there's fluctuations in CO2, that doesn't necessarily, or other greenhouse gases, that doesn't necessarily guarantee that that's the thing causing a temperature change. So why would we think that it's causing a temperature change? Well, the reason is because when you look at two graphs at the same time, you start to see an interesting trend. So up above is the CO2 graph, right? It goes up and down. This is the one we've already seen. And then down below is the temperature one. And if you look, there's a very interesting correlation. Each time the CO2 is high, the temperature is high. Each time the CO2 is down, the temperature is down, right? Sometimes one falls before the other, right? They're not perfect correlations together, but there is a large correlation in general, a large general correlation. So every time spike, low spike, low spike, spike, right? Spikes, two spikes, and then two spikes, right? And then it goes down, and then this goes down. And there is a large correlation between the temperature and the CO2 levels. So that's interesting. We can't prove that that's what's causing it. This isn't proof. But what this is this is showing a large correlation. And so it makes us worry that when one goes up, that means the other one's going up. And since at the last couple of years, we have seen this giant spike on the CO2, right? Remember, in the last couple of years, we've seen this giant spike. Then we're worried that the temperature, right, will also spike. That's the worry. Will it? Oh, I don't know, but we're worried that it will. So as we see this giant spike, that's what we become worried about. Now the question is the next question is, what is causing that CO2 to spike? So there could be different reasons to explain why these other CO2 and other greenhouse gases are increasing. The most common belief is simply that we're burning a lot of fossil fuels. And probably the reason why we're believing this the most is because, again, remember that spike just happened to start right around the Industrial Revolution. And so it's rather coincidental, I think, to have this giant spike right at the time when you're burning a lot of fossil fuels, which we already know give off a lot of CO2 and other greenhouse gases. So it is it's kind of just the simplest explanation of what might be happening, since it just happens to correlate around that time. However, it's not the only one. So other possible causes for the increase in greenhouse gases include the following. Number one, there could be increased volcanic activity. The Earth stores a lot of CO2. Excuse me, the Earth stores a lot of CO2, and during volcanic activity brings a lot of that CO2 out of the ground and into the air. Also, an increase in forest fires. Naturally, forest fires occur all the time because of lightning strikes and things like that. However, with humans, right, we end up creating occasionally more forest fires than we intend, more forest fires than if it was just nature, I meant. And so forest fires, in addition to causing deforestation when the trees are trying to get rid of some of that CO2, the forest fires themselves is burning a lot of biofuel, which creates a lot of CO2 as well, kind of like burning fossil fuels. There are other natural processes as well. I mean, there's other things like just the fact that we have greater population, right? We all exhale and we all breathe out CO2. In addition to that, we all require food. So we have more cattle on the earth now. We have more people on the earth now today than probably the first 5,000 years of the human race, all put together. If you added everybody who lived in the first 5,000 years of the human race, we have more people on the earth now than we did back then. So there's a lot of more people. Now, in addition to needing more food, we also, and more cattle, we also need more space, which means more deforestation and things like that.